Objective: to identify and distinguish between aqueous solutions or solid samples containing carbonate, CO32, sulphate, SO42, and sulphite, SO32 ions. Key principle: we will use their reactions with acids to produce different gases and then use specific tests to identify those gases. We will also use the solubility of their barium salts in acids. Bench reagents required: 1. Dilute hydrochloric acid, HCl, AQ, 2. Barium chloride solution, BaCl2, AQ, 3. Acidified potassium dichromate Zisax solution, K2Car207H 4. Lime water, CaOH2, AQ, 5. Potassium permanganate solution, KMNO4, AQ. Step-by-step procedure and observations. Step 1. The acid test, most important step. Procedure: place the solid sample in a test tube or use the solution. Add dilute hydrochloric acid, HCl, and warm gently if necessary. Observe carefully if a gas is produced and its properties. Observations and inferences. 1. Observation: a colorless, odorless gas is produced that turns lime water milky. The milkiness disappears if the gas is passed through for a long time. Inference: the gas is carbon dioxide, CO2. This confirms that carbonate ion is present. 2. Observation: a colorless gas with a choking, pungent smell like burning sulfur is produced. This gas turns acidified potassium dichromate 6, paper, from orange to green. Inference: the gas is sulfur dioxide, SO2. This confirms that sulphite ion is present. 3. Observation: no reaction or no gas evolved with dilute acid. Inference: the sulphate ion is likely present, as it does not react with dilute acid to produce a gas. Proceed to step 2 for confirmation. Step 2. Confirmation using barium chloride solution. This step is primarily to confirm sulphate, but it also shows the different behaviors of the precipitates. Procedure: to a fresh sample of the solution, add barium chloride solution, BaCl2. Observe if a precipitate forms. Then add dilute hydrochloric acid, HCl, to the precipitate and note if it dissolves. Observations and inferences. 1. For a suspected sulphate, no gas with acid. Observation with BaCl2. A white precipitate is formed. Observation with added HCl. The precipitate is insoluble in dilute hydrochloric acid. Confirmation: this confirms the sulphate ion. 2. If you test a carbonate or sulphite with BaCl2. Observation with BaCl2. A white precipitate is also formed, barium carbonate or barium sulphite. Observation with added HCl. The precipitate dissolves readily in dilute hydrochloric acid, often with effervescence, fizzing, as CO2 or SO2 is released. This differentiates them from sulphate. Additional confirmatory tests for sulphite: 1. With potassium permanganate. Procedure: add the sulphite solution to acidified potassium permanganate. Observation: the purple color of KMNO4 is decolorized. Inference: sulphite acts as a reducing agent. 2. With orange chromate solution. Procedure: add the sulphite solution to potassium chromate solution acidified with dilute acid. Observation: the orange color changes to green. Inference: confirms sulphite is a reducing agent. Summary for quick reference: 1. For carbonate ion, carbonate shows effervescence of CO2 when dilute hydrochloric acid is added. CO2 is colorless, odorless, and turns lime water milky. 2. For sulphite ion, white PPT soluble is formed when BaCl2 is added, which dissolves with effervescence. When HCl is added due to liberation of SO2, SO2 is colorless, pungent smell gas which turns acidified potassium dichromate green. 3. For sulphate ion, no gas is evolved when HCl is added. White PPT insoluble in HCl is formed when BaCl2 is added.